Hi Y10. The purpose of this hopefully short video tutorial is just to provide you with some help on how to navigate Excel and create your graphs and figures for your results section. Now I've collected all of your data here from your experiments that we'll be using. Here you have volume of titrant, in our case sodium hydroxide in milliliters. This is what you would have recorded in the lab, and then I've just converted that to liters here. So you should have already done this for your calculations, but if you've already created your first figure using milliliters, please don't worry about it. It's not entirely important at all that it be in liters. For the purpose of this video tutorial, that's what I'll be using, however. Before we create our figure, I'm just going to add a new column for averages, and if you haven't calculated averages in Excel before, it's actually super simple. So all you have to do is you select your data, you click on this little box, we go to totals, scroll across to averages, and as you can see when you click on the cell, the formula comes up here and Excel has actually calculated that for you. Now we're ready to create our first figure, so select all of the data. Now there's a couple of ways you can do this. You can go to recommended charts, or you can go to a specific type of chart. If we click this, so it actually doesn't have the one that I'm looking for, so if we go to all charts, however, here, this is the one that we're going to use. Alright, nice and simple. So here we have our 4 trials, each of them with a different color, and then we have our average in the dark blue. Before I do anything more though, I just want to change that. So if we click on the average, hopefully it should highlight all 3 columns, and then you right click on one of them. You just want to go to change series chart type. It's going to bring up this window here, and we're going to go down to average. We're going to change it from a clustered column to a line graph. So this is a nice way to differentiate between the 4 trials that we did and the averages, and it just gives us a nice clear comparison. Now the next thing I'm going to do is delete the chart title, because in scientific lab reports, oops, don't want to do that. In scientific lab reports, you actually put a figure title below instead. Sorry, my phone's going crazy. And I'll show you that when we copy and paste that into Word. What we do need, however, is an axis title for both our Y and our X title. So we're just going to delete that and replace it with volume of titrant, which is NaOH in liters. So remember to use your units, it's very important. And down here, we're just going to go type of vinegar. Alright, so you can make this nice and big. There is one more thing we might do. So see down here on the y-axis, you can actually change the intervals between the units. So for some reason it's not going to come up. Nope. So if you go to text options and then back to axis options, for some reason it comes up with what we're looking for, but you can actually change the units. So what we're going to be changing is the units, the major units, from 0.005 to 0.0025. And then we can make it a little bit taller. And that just hopefully helps the reader differentiate between the 4 trials, because especially with the Coles and the Cornwell's white vinegars, there's not much difference between them. Alright, so that's our first figure that we have created, so not too hard. We're going to go on now to the concentration of the analyte, which in our case was the acetic acid, in moles per litre. Again, all you have to do is select the data, insert. We're going to use a line graph this time. And again, we'll make it a little bit bigger. Delete our chart title. Add our axis titles. We actually don't need this because they're pretty informative as is. But we do need to change this. Concentration of analyte. CH2COOH in moles per liter. So hopefully you have noticed that when we've written out our acetic acid, so CH2COOH, that 2 right there should be a subscript. For whatever reason, Excel actually doesn't let you do that, and you just have to change it when you copy and paste this into Word. So I'll show you that later as well. Again, so the intervals between the y-axis are a little bit too big for my liking. So again, we just click on here, text, back to axis options, and then we can change the major to 0.01. Doesn't make a whole lot of difference, but yeah. There's another thing that you can do. If you just click on the fill and line button and head down here, you can actually use a smooth line. Now, you might prefer to use the straight hard edged lines, but for some reason I like the look of the smooth lines. Again, it's completely, entirely up to you. So there's our first 2 figures. What we can also do, we can also create a final figure for the averages of concentration between them. So again, to create the average, we just say totals, average, and then we can make up a new data set over here. And just paste that in. Whoops. We want to paste it through as values. There we go. So this is our vinegar type, and this is our average concentration in moles per liter. There we have it. So then we select the data, insert, recommended charts, and this time we can actually use a clustered bar if we want to be a bit different, or you can use a clustered column graph again. Obviously don't use a pie graph, that's not appropriate for what we're trying to show. And here we go. Let's make that a little bit longer. Again, delete this, add our axis titles in. So type of vinegar and concentration of analyte. Oh, sorry, you should write average CH2 COOH in moles per liter. And there you have it. So we've got 3 figures now for our data. What you can do is go to our Word document. So we get the first one, copy, and paste. So that's a pretty good size. It's the size that you should be looking for. You want your readers, your audience, to be able to interpret the graph very easily. If you make it like tiny, the reader's not going to be paying attention to it. So this is the most important thing, besides, I mean, your discussions up there as well, that your readers are going to be paying attention to. So you need to make sure that you're bringing lots of attention to it and that it's nice and clear. So earlier I was telling you that we don't use chart titles, that we use figure titles instead. So it's really simple to add these in. So you just right click and you say insert caption. So you can either type it in here, or you can just press OK when it's empty and put it in there. So figure 1, it is the volume of titrant NaOH titrated into 3 brands of vinegar. And then you can even say, so the Coles white vinegar, Cornwell's white vinegar, and Coles white wine vinegar. Easy done. So the good thing about this is that with this figure title option is that when you add in your second one, so this one here, so we can actually, when we right click and say insert caption, it actually keeps track of what figure you're up to. So I remember in term 2, some of you guys had 2 figure 1s, so this will hopefully keep track. Just remember, however, so the purpose of putting these figures in there is to have something to talk about. So you don't actually mention figure 2 until after you've talked about figure 1. So if you decide that you want to talk about this one first, just make sure that the figure titles are consistent with that. And then you would add a caption here. Remember to be descriptive, and I'll show you, oh, that's frustrating that it's not in center, but anyway, so I'll show you here with this CHC2. If you just press Control and then equals, that will actually make that number into a subscript, which is what we want. There is another way that you can do it. So there is a bar up here which you can just a button up here that you can click, and the words, the letters and numbers will be in subscript. There's also an option for superscript as well, but we won't need them for the purpose of this report. Let's see. So yeah, so this is our results that we have. So you can see that there is a major discrepancy between trials 1 and 2 and 3 and 4 for our Coles white wine vinegar. So that's actually providing you with something to discuss when you're going through your analysis of results in your discussion. So that's probably a great example of experimental error. We should have gone back and maybe done some more trials and discarded the one that was inconsistent with the actual the majority of the results. So we actually don't know which one of these is wrong or right, and that's something that you can look to fix, and you're talking about it in your limitations. Because you guys broke off into different groups, you actually don't know what the other groups did wrong, or even if they did anything wrong, but it is very unlikely that these are natural results. So one of these is likely to be incorrect. But yeah, lots to talk about. Hopefully this video has helped navigate this a little bit better for you. If you do have any questions, please let me know. And yeah, I will see you guys all in class.